20 meters. Floating at a water line of 6 meters. Let us say this is the forward end, this is the aft end. So you have a compartment somewhere here, length 30 meters, breadth 20 meters, and this distance is 10 meters from the forward end. Is this the intact condition? And the compartment has permeability, so I'll show the cargo. Guys, is this the diagram in the intact condition? Yes or no?
Yes, sir. Correct, sir.
Anybody in the class? Now don't struggle with the diagrams. Last opportunity, each step. But you have to come with your doubts at the step itself. Now, in this diagram, when the compartment gets bilged, can you please shade the lost buoyancy? Please shade the lost buoyancy. I'm sure you would have done this. Yes or no? Correct?
Correct, sir.
Now, this will cause the vessel to sink. Draw a even keel W1L1. I know vessel will trim, but LCB, which you pick up from the hydrostatic particular of MV Hinship, they are for even keel upright condition. So we'll be calculating the LCB for the even keel condition. Therefore, we are drawing W1L1 as a even keel line. So please draw W1L1. It will cause the vessel to sink to a new even keel draft, high draft rather, D1 W1L1. Will the water rise between WL and W1L1 class?
Yes, sir.
Will the water? So
Yes, sir.
please do the needful. And the even keel draft, you can mark it anywhere. It doesn't matter whether you mark it here or mark at the end. We know we are talking of even keel draft of D1. Doesn't matter where you mark. Okay. Now, right below this, please make the water plane area in bilged condition at which level? W1, L1. Can you please make the permeability is 30%. Please draw the water plane in the bilged condition at W1, L1. Is this the diagram of the water plane in the bilge condition? And of course, there'll be a partial loss here because of permeability. Is this the water plane, guys? Any change from what we did in the previous two classes? Nothing?
Nothing,
Yes
sir.
or no?
Same.
Very good. Now, using whatever you already know, please calculate the sinkage now. Since the water plane between W1, L1 and WL is same, then it will be lost buoyancy divided by intact water plane.
Zero 0.593.
0.593 meters. Everybody is good with it? Sinkage? Yes or no? Correct, class?
Yes, sir.
So, one thing we have got, D1 will be 6.593. So one thing we have got is D1 6.593. I'm writing here whatever I need. What all we decided with the formula? We'll need in the bilged condition LCB. We'll need in the bilged condition LCG. We'll need in the bilged condition LCF. And we'll need in the bilged condition BML. BML. It is not right. Now, guys, we'll deal with other questions later on. here in the intact condition, when the vessel is even keel, is there any relationship between, okay, firstly, which method are we following? Tell me, which method are we following?
Lost points.
Lost
Lost
point.
point.
Buoyancy.
So now we are calculating LCG, guys. So will the LCG final be same as LCG initial? Yes or no?
Yes, sir.
Why? Because we are
lost points
following
means that
lost buoyancy. We are following lost buoyancy. Guys, in the initial condition, can you see any relationship between LCB initial and LCG initial?
Both are equal.
Why they are equal?
vessel is
Even
in
keel.
intact condition.
Intact
Even
condition.
even keel.
Lost buoyancy method LCB
Even
is
keel
same.
में है ना sir.
Even keel.
LCG is same.
Even keel.
My question is, do you see any relation? Somebody is still saying LCG is same, LCG is same. My question is not heard only. My question is, do you see any relationship between LCB in the intact condition and LCG in the intact condition? That was the question. And you are still saying LCG is same, unchanged, lost buoyancy method. हाँ भाई,
Sir, same
what
है
is
ना. Vessel is in even keel.
Vessel
So
is
box
in-
shape vessel even keel draft.
Sir, LCB is equal to LCG.
Yeah, okay. Tell me one thing. If it is a ship-shaped vessel and on even keel, will LCB and LCG not be equal?
Still be equal.
Sir, will still be equal even keel.
So why this box-shaped? When you are equating LCG initial equal to LCB fine initial, has it got to do with the shape of the ship or has it got to do with the even keel condition?
Keel condition.
Even keel condition.
Because the trimming moment is zero, correct? Correct, guys? And trimming moment
Yes,
will be
sir.
zero when LCB, LCG difference is zero. Correct? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
And what is the relationship between length of a box-shaped vessel and the LCB?
Half
Half
Half of what? Your
of the
height.
length.
of
the
length.
तो
Half
पूरा
of
बोल
the
लो ना बेटा, पूरा बोल लो ना फिर. LCB initial is L by 2 because it is box-shaped vessel. Do you agree with these three statements that I have written here? Do you agree with them or do you have any problem? Bolo bhai, what does it take you to? It takes you to LCG final is equal to LCG initial. LCG initial is equal to LCB initial. LCB initial is L by 2. That means 50 meters. What does it mean? That means LCG final is L by 2. Yes or no, beta? Am I
Yes,
right?
sir. Yes. Sir.
So here we don't have to, we though no calculations were required, we can qualitatively make an inference that LCG final is 50 meters. Anybody has any questions? Out of 5 things, 2 things are already there on the board. Everybody's good about it, beta?
Yes, sir.
Okay. Now, let's calculate LCB final. Guys, over last 2 days, we have learned how to calculate KB final in the Bilging condition. Have you learned that? Correct?
Yes.
Yes. Yes. Correct, sir.
We know how to calculate. So how were we calculating if it was required to be calculated? By taking
By
vertical moments, correct?
Yes, sir.
And for LCB and LCG, which moments do you take? The reference axis shifts to the after perpendicular. You take longitudinal moments, correct? Right?
Yes, sir.
For
Yes, sir.
KB, now I'm saying what statement were you making to yourself for KB? You are saying vertical movement of the underwater volume up to W1 L1. Now we'll replace the word vertical with longitudinal. Longitudinal movement of underwater volume up to W1 L1. Then from in vertical moment, what are you doing? Minus the vertical moment of underwater volume not contributing to buoyancy. Now what will make it? Longitudinal moment of underwater volume not contributing to buoyancy divided by volume of displacement. Correct, beta? Yes or no? Am I right? Correct, guys? Can you repeat to yourself? Longitudinal moment of underwater volume up to W1L1 minus the longitudinal moment of the volume, underwater volume not contributing to buoyancy divided by volume of buoyancy. Yes or no? It is the same statement, only thing vertical moment has been replaced by longitudinal moment, right? Am I right, class? Clear?
Yes, sir.
Okay. So,
Yes, sir.
okay. So if I have to find the longitudinal moment of underwater volume up to W1L1, first I'll identify the volume, then I'll multiply by the lever. So what is the underwater volume up to W1L1? I'll write the volume and I'll ask you to give me the lever. L, B, D1, D1. This is the underwater volume. What will be the longitudinal lever of this volume, guys?
L by 2. Capital L by 2.
Okay, somebody he says L by 2. I don't know. Others agree with him or disagree with him? Class,
Yes,
what is the
Breadth by 2. Breadth by 2.
breadth by 2?
Length by
Excuse me, sir. Should we show the axis in the diagram also?
No need. Why should you show? You're talking to yourself, you're writing in the notational form, no? There's no need to show.
Okay.
No need to show. Because the diagram already is so cluttered, why unnecessarily clutter it? If you show there is no harm, but there's no need to show. If you're saying, will it affect your eval marks? No, it will not. Okay. So guys, what will be the longitudinal lever of this volume LBD1? It's box shaped.
L by 2.
L by 2. Very good. From here, I'll subtract the longitudinal moment of underwater volume not contributing to buoyancy. It will break into two parts. First, identify that volume. Give me that underwater volume not contributing to buoyancy in the notational form. Can you give me that volume?
Small l into small b
P into
into
small
D1
l.
into permeability.
Is he right, guys? I have written because he said so. I don't know. You have to tell me whether he's right or wrong. Is he right, beta? Is he right in identifying the underwater volume not contributing to buoyancy, class? Yes or no? Bolo bhai?
Yes,
sir.
Okay. So where will be the geometric center of this volume? See, I'm coming to the diagram. The geometric
75
center of this
meters, sir.
volume will be here. Its lever will be this much. Let me call it as X. This is 75 meters. Does everybody agree the lever is X and value of X is 75? Yes or no? Class, is that clear?
Correct, sir. Yes, sir. Correct.
So into X, since I'm writing everything in the notational form, I've already loaded the diagram with X. Divided by volume of displacement, L, B, D. So guys, there is no change in the method you are calculating KB. Only thing is, instead of vertical moments, you just have to switch to longitudinal moments. That's the only thing that is happening. The axis is changing, rest everything is same. Can you please put all these values and give me the LCB final, guys? In the next step, put the values, and the third step, calculate on the calculator on the run. And
47.527.
I am just writing whatever you're saying, 45.7.
47.527.
47.527 meters. Okay, subject to
Excuse me, sir.
validation.
Isn't
Yeah.
it volume of buoyancy in the bottom?
Which one?
Below LC for the LCB denominator.
In KB, what is the denominator? What do you want to take? In KB, what were you taking?
The difference in volume.
Okay, so take the difference, no problem. Take the difference. And tell me what is the answer you're getting. Take the difference, no problem. Samuel, why you want to waste your time in the exam? मुझे समझ में नहीं आ रहा. You don't attend the classes, or you were not there when we were discussing all this?
I don't know.
No, you can take the difference. There's nothing wrong. It's okay. Take the difference. It's okay. You want to go in a roundabout manner? Please do. No problem. Guys, is 47.527 or 525, is it correct? Yes or no?
Yes, sir. 5 to 5 is correct, sir.
5 to 5, 5 to 7, both are correct actually. I know what he's done. He would have taken the LBD1 minus LBD1P in the denominator, then it will come 0.5 to 7. If you take LBD, it will come 5 to 5. That is because D1, the sinkage of 0.593 was rounded off to third decimal place. So doesn't matter. So what did you get with this LBD? 47.525, right? So I'll,
Yes, sir.
525.
5 to 5.
okay, and if somebody has got 47.527, please don't think it's wrong. It's okay. Actually, that is more accurate because of this 5 to 5 is coming because of use of D instead of what Samuel is saying, this minus this. If you do this, you will get 5 to 7. Understood, Samuel?
Yes, sir.
Okay. Now, so we have three things done. Now we go to LCF. Now, guys, in this case, LCF will be equal to LCB final. And that will be, if it is 47.527, it is 47.527. If it is 47.525, then it is 47.525. Doesn't matter about that. I know why the difference is coming. So that difference is not wrong. Okay, that's understood. Now, when will LCF be equal to LCB? Guys, you know when KB will be D1 by 2? You know the condition? Yes or no? What is the condition for KB to be D1 by 2?
The water plane area and beige condition should be identical from end to keel.
From keel to W1 L1, right?
Yes, sir.
Yes.
If that condition is satisfied, then your LCB and LCF will be equal. It is like this, beta. This volume comprises of water plane areas. If all water plane areas are same, then the geometric center of the water plane areas will be in the same line. So whatever volume they make, the geometric center of that volume will also be in the same line. Yes or no? Correct? Correct, guys?
Yes, correct.
Okay.
Yes.
But if you, yeah, but you can always link it to KB. That if the water plane area is identical from keel. So if you want to take straight away, cut short and write it same, then you have to write that statement here again, which you are writing for KB is equal to D1 by 2. As the water plane area is identical from keel to water plane area W1 L1, LCB and LCF will, LCB final and LCF final will be equal. So LCF will also be whatever LCB you got. But guys, is it always going to be the same? No, it was never the same in even KB. Many a times we had to calculate that also. So we can also calculate LCF. Let me calculate LCF, and I know it will come 47.5 to 7 because that is more accurate, but don't worry, 5 to 5 is good enough. It's okay. For LCF calculation, we'll take the moment you have done in Simpson's rules. We'll take the moment of the areas about after perpendicular. So guys, if I have to calculate LCF, my focus has to be on this diagram. What do I need? I need the moment of the intact water plane about after perpendicular, which you used in Simpson's rules. and you have to divide by the intact water plane area. Correct, guys? You are getting the moment of area and dividing by area to get the distance of GC, right? Am I right? In Simpson's rules. Correct? In Simpson's rules, when you are finding AF, what were you doing? You are getting the moment of the water plane area about after perpendicular and dividing by the water plane area. Correct, guys? Yes or no?
Yes, sir.
So here we'll be dealing with the intact water plane. So now I will make some statement. I'll repeat it as many times as you want, and then I'll ask you to give me in the notational form. If I want the moment of the intact water plane about after perpendicular, one is I take moment of area 1, then I add moment of area 2, then I add moment of area 3. That is one way. The other way is from the moment of the full water plane, whole water plane, I remove the moment of the lost water plane. Then I'll be left with the moment of the intact water plane. Am I right, guys? Yes or no?
Correct, sir.
So, guys, first I'm saying now pay attention. Longitudinal moment of the whole water plane. So, first you will identify the water plane in the notational form, whole water plane, and then its lever from the after perpendicular. So, what is the whole water plane in the notational form, guys?
Capital L, capital B.
Capital L into
Capital L.
capital B. And what will be the distance of its geometric center from the after perpendicular in the notational form?
Capital L by 2.
L by 2.
L by 2. From this whole moment, if I remove the moment of the lost water plane, so first we identify the lost water plane. How much is the lost water plane in the notational form, guys?
Small L, small b.
Small l into small b
P, sir, P.
Into
into p
Into
into
75.
p. Very good. Correct. And where will be the geometric center of this one? Here. What will be the lever? X, 75 meters. So into x. This will give me the longitudinal moment of the intact water plane. And if I divide by the intact water plane, what do I divide with? Intact water plane is whole water plane minus lost water plane. And if you put the values here, you'll get 47.527 meters. This 2 units in the third decimal place, we know why it is coming, so it is not bothering us. It is because this 0.593 was rounded off, and here we took D. Had I taken this minus this, I'll get the same. So it doesn't matter whether you're working with 47.525 or 47.527. Do not worry about that as long as you know why this difference has come. Guys, if there is a need to calculate LCF, will you be able to calculate by principle of moments? Yes or no? Correct? Is that clear, class? Class, is it clear, beta?
Yes, sir.
Now, guys, you have to understand one thing, that if you see in a question that both LCB and LCF are equal, then you have to calculate any one of them. And then you can put that statement and make the other one equal. You don't have to waste time. If you want to calculate both, it's your choice. Nothing wrong in it. But there is no point in wasting time. If you see both are equal, you can save some time by calculating one of them and continuing your working. But if you want to calculate both of them, by all means, you can do that. There is nothing wrong in doing it.
Excuse me,
clear?
sir.
Yeah,
Could you dictate
tell-
that statement once more, please?
Samuel, this was repeated yesterday, and somebody had asked it yesterday also. And yesterday, in 2 questions, I said, can you please put down this statement before you say KB is D1 by 2? Were you again not in the class yesterday also?
No, sir, that I understand because it was KB.
No, but yesterday when I said, when in 2 questions we took KB as D1 by 2, I put a box and I said, please put your statement here. I want you to recall and put the statement.
Yes, sir, I remember that statement. But
So did you put that statement yesterday?
Yes.
So it is the same statement. What was the statement? Read from the previous question. What is it?
Just give me a second, sir. I'm finding it.
Yeah, no problem. I know I could have told the statement in this much of time, but if today you can't connect to that statement, then in 4 days you will not be able to connect anything with anything that we have done in the class, beta. Yesterday in 2 questions we had KB D1 by 2, and there I remember very clearly I said I'm putting this box, please put down your statement. Yes or no?
Yes, sir. Yes, sir.
What was it?
As the water plane area in bilge condition is identical from the keel to the water line.
Water line
W1L1.
W1L1, right?
Yes, yes.
So therefore LCB will be equal to LCF, or LCF will be equal to LCB, whatever you want to write. Okay.
Okay.
Yeah. So these are not new statements, they are repeat of what. Okay, guys, I'll take it on the next screen because I don't want to mess it up further. I'll make the water plane separately, though we'll work on this water. We can work on this water plane only. Okay, let me work on this water plane. I'll go to the next one later. Okay. Now, what is left in the table, in the things that we need? D1 we have, LCB we have, LCF we have, LCG we have. Only thing missing now is, correct. Guys, in moment of inertia, what was the formula for BML? What was the formula for BML, class?
IFF by
ICL intact water plane upon volume.
ICL, very good, Amit. Shabash. That was the formula for BML you had done, is it?
IFF by the volume of
I
displacement.
powered up.
Guys, if you keep forgetting everything that you are doing, then you are inviting trouble for yourself in the exams here. What is the formula for BML?
Inertia work divided by volume of displacement.
I what? I of what, beta?
FF.
And what? Which moment of inertia? What? Yeah, I said two things, Dolrich. One is FF, other is what? Intact water plane, correct?
Yes, intact water.
Okay, so guys, now we have LCF. So what I'll do is, on the water plane diagram, I'll mark the center of flotation. Why? Because unless I mark the center of flotation, I cannot draw the athwartship axis. And I draw the athwartship axis through it. And this is what we are calling as FF. Am I right, why guys? Yes or no? Please tell me. Let me change to green marker for this working completely. It will be a separate thing. So guys, what is the formula for BML? Now, you see, the problem is if you keep forgetting what you're doing, then you'll have problems. It will be IFF of the intact water plane upon volume of displacement. Am I right, guys? Correct? This is the formula, correct,
Yes, sir.
class?
Yes,
And
sir.
what will this be equal to? This will be IFF of the whole water plane minus IFF of the lost water plane. Am I right in writing so? Divided by volume of displacement. Am I right, class?
Yes, sir. Yes, sir.
Anybody has any questions up to this point, please let me know. Now, I am asking myself a question. Now, this distance, we have already calculated. This distance is 47.525 or 527, whatever you're taking, doesn't matter. Okay, guys, is FF a standard axis for the whole water plane? Yes or no?
Yes.
No, sir.
Yeah.
FF is standard axis for the whole water plane?
No, sir, no.
Yes, sir.
No, sir.
Who said yes? I would like to ask him. Then what formula do we use for getting the moment of inertia of IFF of the whole water plane? Who said yes? Samuel,
I
you
said
said yes?
so. Yes.
Is FF a standard axis for the whole water plane?
Yes,
Tell
sir.
me.
It's a standard axis. It is through the centroid.
Centroid of the whole water
Okay.
plane?
Yeah. No. Yes. Sorry. My bad.
Okay. Anybody who still feels yes, FF is a standard axis for the whole water plane? No. So FF is not as to why, because F is the geometric center of the intact water plane. It's not the geometric center of the whole water plane. The geometric center of the whole water plane will lie somewhere here at G1 at a distance of half the length, 50 meters. Correct, beta? So I draw a parallel axis through it. I can call it as YY. G1 is, what is the distance of G1 from the after end? This is 50 meters. Correct, beta? Am I right?
Yes, sir.
Yes.
So what is the distance between the parallel axis? Let me call it as X1. X1 is how much? It is
2.475.
2.475 meters. Guys, you have to load the diagram properly, because when you start writing, everything will be then readily available from the diagram. My next question is, IFF of the lost water plane. Is FF a standard axis for the lost water plane? Yes or no?
No, sir.
No.
No. So we'll have to deploy theorem of parallel axis. Here is the geometric center of the lost water plane. We draw a parallel axis to FF. Let's call it as ZZ. You can name them whatever. What is the perpendicular distance between FF and ZZ, guys? Let me call it as X2. Can you calculate how much will it be? X is 75, AF is
27.4.
47.2525. How much is X2?
27 point
27 point
475.
475 meters. Now, I'm sure you have understood why we have marked these X's, because for BML, you'll have to deploy theorem of parallel axis. Guys, it is really very disheartening at times when I'm asking BML, people are saying ICL and all that. You need to be little more careful if you want to really have favorable results here. Guys, now this implies BML. Now you will tell me, now guys, I'm putting this box bracket here. Apply theorem of parallel axis for the whole water plane between YY and FF. Tell me. I'll keep writing as you speak.
सर नोटेशन में बताना है या क्या?
Notation, of course.
So it will be BL cubed by 12.
No. First, apply the theorem of parallel axis.
It will be IXS of the whole area.
IYY. It will be IYY of what? Whole water plane. Right, guys?
Whole water plane.
Once you write this, then even if you don't write in the notational form, then it will be easier for you. Plus area of the whole water plane into x1 square. Am I right, guys? Yes or no?
Yes.
Yes, sir.
Yes, sir.
Then minus, I apply the theorem of parallel axis between ZZ and FF for the lost water plane. IZZ of the
ZZ
lost
area
water
plus
plane.
Lost water
A
plane
Very good.
plus
Y
A
square.
plus
Plus
X2 square.
area of, very good, lost water
Lost
plane into x2 square. Correct, guys?
Sir.
Divided by volume of displacement. Am I right? Yes or no?
Yes, sir.
Does everybody agree? Now, please remember, when you open the second box bracket, this minus will make this one also minus. Both the third and fourth terms have to be subtracted. I hope you don't mess it up, right? Now I'll take it to the next sheet screen. Okay, guys, now tell me, Now you'll tell me straight away values. BML will be, what will be IYY of the whole water plane? What to multiply and divide with what? IYY of
20
the
into
whole water.
100 cube by 12.
He says 20 into 100 cube by 12. Is he right, guys? If you don't agree, please correct him.
Yes, sir. Correct.
Okay. Then everybody's okay with this first expression, IYY of the whole water plane, guys? Yes or no?
Yes, sir.
Then
Yes, sir. Correct.
plus the area of the whole water plane will be 100 into 20. X1 is already in the diagram, beta
2.475 square.
2.475. So pick up from the diagram and straight away square. Now be careful. The minus is outside the bracket. Both expressions will be, if I remove the bracket, both have to be minus. Guys, what will be IZZ of the lost water plane in values? Tell me.
20 into 30 cube by 12.
20 into 30 cube by 12. Anything else?
Into 0.3.
Into 0.3. Very good. Permeability. Somebody said permeability. Somebody said 0.3. It's okay. Into permeability. Minus. This will also
20
become
into
minus.
30 into
Yeah.
0.3.
20 into 30 into 0.3 is the lost water plane area. And
Into
X2 is in the diagram
47.5
27.475 square. Divided by volume of displacement. Samuel, volume of displacement under lost buoyancy does not change. That was the reason why we use the same LBD there also. 100 into 20 into 6. And now what you have to do is just use your calculator very efficiently and calculate the value of BML and give the answer. This answer I'm taking from top. It will come
127.462.
27.462. Please calculate. Let me know once you have tried your calculator. Guys, there is nothing much that you are learning today. It's only the trim concept, applying what you already used to do in trim and what you have learned over last 2 days. Yesterday also I told you, if your last two classes are effective, this will also be effective. But you can't allow the formula to go for a toss. Whatever we did in moment of inertia, BML, BMT, you have to be clear, guys, about it.
Yes, sir. Correct. Value.
Okay, anybody still calculating? Tell me. Guys, is the kg given in the question? I'll show you the question also. Is the kg given in the question?
Nice.
Please tell me. So that means we can't use GML, am I right?
Yes, sir. We will be using BML.
So the trim in the bilged condition in centimeters will be LCB difference LCG. So 50 difference, or you can put minus, no problem. 525. This is LCG difference LCB because LCG is greater here. Into 100 into L. The L is 100, so another 100 for L divided by BML 127.462. And this will give you trim in centimeters. How many centimeters does it come, guys?
194.2.
If anybody has any question on calculation of trim, please let me know. And also tell me whether it is by head or stern.
By head.
By head.
Because LCG is greater. Okay. Everybody's good with this, guys? Yes or no? Guys, anybody stuck with BM calculation or trim? Please let me know. I'll wait. We'll split the trim into TA, TA. TA is trim 1.942 meters, which is equal to 1.942 meters, right? Into LCF 47.525 divided by length 100 meters. How many meters is that TA, guys?
0.92.
923.923.
And we get the TF, total trim minus TA. So this will be 9, then 1.019 meters. Now we are good to get our answer, beta. Forward, aft. What is, you can call it height draft, or you can call it whatever you want to call it. Height draft is D1 6.593, 6.593. TATF. Please be careful. TA should go under aft. This is another area of mistake. TF 1.019. As the trim is by head, TF will be added, TA will be subtracted, and this shall give us the post-bilging drafts. And answers are 7. I'm picking from the answer. I'm not doing addition subtraction. 5.670 meters. And these are the answers to the question. Now, please review the full calculation from beginning to end and let me know if any area needs to be, so that if you have similar questions, then you should be just running away with the solution, guys. Guys, is it okay? I don't see anybody asking any questions. Is this okay, or you're still reviewing it? Please let me know. If I don't get response over next 5 seconds, I'll move to the next question, guys. Okay. Let's go to the next question. This is MMD May 22. So if you are able to solve this by yourself, I think that will give you some confidence. Can you make the side elevation of the vessel in intact condition first? Can you please do that? Please make the side profile in the intact condition first. Obviously, what am I saying? You have to mark whatever information can go on the diagram in that condition. Is this what you have made, guys, in the intact condition side profile? Yes or no?
Yes, sir.
Yes, sir.
Okay. Guys, I'll be basically now giving you a lot of lead and you have to start solving. Next, shade the lost buoyancy. Now draw W1 L1. In the you can draw even keel W1 L1, no problem. And this will be your D1 wherever you want to mark. Doesn't matter, guys. As I said, it's a even keel draft you're marking. Will the water rise between WL and W1 L1? Yes or no?
Yes, sir.
Very good. And do the needful. Guys, now can you please calculate the final height draft 7.314? Okay, first make the, okay, sorry, my mistake. Let's finish the diagram. Make the water plane area also beneath it in the bilge condition. Please complete the diagram first. Water plane area at which level? W1, L1. In which condition? In the bilged condition. Now, somebody may feel why we have taken the breadth of the compartment as 18 meters. Because question has not specified if it's a cargo hold. Usually ships are single skin. So they extend from side to side. Why I'm addressing it is, it's a MMD question. You should not unnecessarily get stuck there. Now, can you please calculate the height draft and confirm if you're getting 7.314? And if anybody is not getting, I'll not even write the steps now. If you're not getting 7.314, then I'll ask you what have you done, and then I'll push you from there. Got it, guys? 7.314, D1. Please calculate D1 and tell me 7.314.
Yes, sir.
Okay. Guys, if anybody is still calculating, he can unmute and ask me to wait. Is anybody still calculating? D1? None? Very good. Put the D1 on the diagram then, 7.314. Okay, guys. Now, with the steps, write down how much is the LCG in the final condition. It is 80 meters. Answer you can see. But is it what steps to write? Please write clearly and confirm. Have you written and got it, guys?
Yes, sir.
Here LCG will be 80 meters. There is no need to calculate. It can be qualitatively with reasoning. It can be arrived at 80 meters, half the length. Anybody who's not been able to close out this LCG part, guys? See, I'll only help you in whichever place you are getting stuck. So shall I assume two things are done? High draft is fine. LCG is fine, guys. If you don't want to write three expressions, you can write one. You can write like this. LCG final. LCG final will be equal to LCG initial, which will be equal to LCB initial, which will be equal to L by 2, which is equal to 160 by 2, that is 80 meters. And here you can write, lost buoyancy method, even keel, box shaped. All these three will make this expression valid, or you can write three different steps as I had written earlier. Everybody is done with it, guys? Okay. Look at the diagram, guys. Tell me, is LCB going to be same as LCF? Yes or no?
Same, sir.
Is,
Identical.
will LCB and LCF in the Bilge condition be same? Yes or no, class? Please tell me. Fatapat. So
Yes,
what
sir.
do you want to,
Yes.
so what do you want to calculate? You want to calculate LCB or LCF? Calculate any one of them. Which one you want to calculate, so that, because there will be a, I said in the third decimal place there can be a slight variance.
LCB.
Doesn't matter.
LCB, sir, LCB.
Okay, calculate LCB then, guys. I don't know whether I have calculated LCF or LCB. You calculate LCB, no problem. Answer is on display. Talk to yourself silently. Longitudinal moment of underwater volume up to W1L1. Put down the expression, minus the longitudinal moment of underwater volume not contributing to buoyancy, divided by either the difference, as Samuel was saying, or volume of displacement or volume of buoyancy, which will remain same as LBD because we are using lost buoyancy method. Understood, Samuel? So you can save
Yes, sir.
time
I
by...
was just confused because of the permeability. I thought that when it is permeability, we had to use the other way.
No, but volume of displacement or volume of buoyancy will change only if the displacement has changed, right? And under lost buoyancy method,
Yes,
displacement
yes,
does not change, right?
Does not change. Yes, sir. Understood.
Okay, fine. Please let me know how much you are getting. I think you may get 068 if I'm not mistaken. If you're calculating LCV, I don't know. I don't remember which one have I calculated. See, guys, I've intentionally not digitized the
Yes,
solution.
sir. I got 76.068.
Yeah, 068 LCV. But this is LCF. What I have calculated here is LCF. Okay, no problem. It's okay. So you can continue using 068. There's no harm. There's absolutely nothing wrong in it. Don't worry. Don't get worried about it. And Samuel, if you do your way, difference of two volumes in the denominator, then you will get there also 071.
Yes, sir. Yes, sir.
Okay, because as I told you, it is because the sinkage has been rounded off and we are not using D1 in the denominator. That is the root problem, right? Of this 0.003 difference.
Yes, sir. Yes.
Okay. Guys, everybody's got LCB. Please let me know if anybody needs. Now, tomorrow, if you say we don't know how to get LCB, that will be very annoying, guys. Each step, wherever you're getting stuck, sort it out. Ali, Keshav, clear?
Yes, sir. Clear.
Okay.
Already calculating.
Okay. Sahil Yadav,
क्लियर सर क्लियर
क्या कैलकुलेट किया बेटा? LCB कैलकुलेट किया, LCF किया?
LCB किया सर LCB.
Okay. Will LCB and LCF equal? Write the reason for that. Please write the statement and then say LCF also is same. Please put the statement. As the water plane area is identical from keel to waterline, LCF will be equal to LCB, and you have got 76.068 perfectly in order, nothing wrong in it. Guys, does this question have kg given? Yes or no?
Yes, sir.
So what are we going to use? GML.
GML.
Okay, so you'll also need kb. Please tell me how much would be the kb in this case. Give the reason for that also and calculate kb. So LCF, LCB is done. Now you're doing kb.
Sir, D1 by 2.
Very good. Give the reason and make it D1 by 2. Guys, I've not solved anything. You are solving it, and I presume you're solving it well if you're getting the answers. Okay. Now, guys, now pay attention, those of you who may struggle with BML. Your LCF is 76.068. That means it will be slightly aft of midships of the whole area. Put center of flotation beta, puts F and draw athwartship axis FF. Let me repeat these steps with you again as you are doing. What was I trying to say? I was trying to say, put the center of flotation and draw an athwartship axis through it. And you can call it as FF if you want. Change the to it. Now, guys, first write the formula for BML. BML will be IFF of the intact water plane divided by, this is how you'll write in the exams also, guys. This will be equal to IFF of the whole water plane Guys, am I audible?
Yes, sir.
Okay. Did you hear me? Because my headset was giving problem. When I was writing this formula, IFF, lost water plane upon volume of displacement, were you getting me? Yes or no?
बीच में चला गया था.
Okay. So whatever I've written in red, is that clear, beta? This BML expression that I've written in red is clear, or anybody has any questions to ask? That's good, guys. Bolo bhai.
Yes, sir.
Yes, sir. Yes, sir.
Okay. Now ask yourself a question. Is FF a standard axis for the whole water plane? Answer is no. Why? Because it is not passing through the centroid of the whole water plane. So mark the geometric center of the whole water plane. You can mark it as G1, capital, small, doesn't matter. If this distance is 76 point something, 068, I'm putting 68, which you've got. Then obviously center of this geometric center is at 80 meters. The geometric center will be forward of it somewhere here. We can draw, we'll have to apply theorem of parallel axis. We draw a parallel axis through here. We can call it as XX, AA, BB, whatever you want to call it. You will need this perpendicular distance between them. You can write this here, X1, because we have already used X earlier. So you can use this as X1. How much does it come? 80 minus this. How much would that be, guys?
3.932.
932 meters. Very good. Then next I ask the question, is FF a standard axis for the lost water plane? Answer is no. I identify the geometric center of the lost water plane. We already know the distance X from here to here. We draw an athwartship axis. We can call it YY. This distance X, we already know. How much X you got, guys, earlier? In LCD, you would have used how much X did you get? Distance of YY. Sorry.
107.5.
107.5 is X. So now you have X and you have LCF. So you can find out this distance, mark it on the diagram, wherever you can find, and make use of pen and pencil, guys. This X2 is 107.5 minus 76.068. How much does it come?
31.432.
23 point?
31.432.
31.432.
432 is 432 is
42.
no 3. Okay, 0.3. This is 3. No, this will be 2 and 3. Okay, this is 2. 432. Okay. Now, guys, we are good to put everything in order. Now, if you want to use L, capital L, small l, your choice. Otherwise, you can directly do it, no problems. But in the first place, I would always suggest put that, because then otherwise, many a times on the run, you forget to minus the two expressions. So by theorem of parallel, to avoid mistake, these steps are recommended. If you want to just go to complete shortcut, as long as you don't mess it up, it's okay. So it will be I xx of the whole water plane plus area of the whole water plane into x1 square. And this will be I the lost water plane plus area of the lost water plane into x2 square upon volume of displacement. And now we can put these values because now we know that what we are calculating. Whole water plane area will be my eyes go directly on the diagram. On the water plane diagram, 18, so 18 into 160 cube by 12 plus area is 180, 160 into, 18. X1 is already in the diagram, 3.932 square. The other two expressions will be both minus and minus, guys. Don't mess it up. Minus small b is 18. Small l is 25 cube by 12. If it was empty, it has permeability of 0.8. So into 0.8 plus will become minus. So the lost water plane is 25 into 18 into 0.8 into x2 square, which is 31.932 square, divided by volume of displacement. Volume of displacement is capital L 160, capital B 18, and draft 6.4. When you solve, unless I have made any mistakes in writing, this should solve to 315.436 meters, right, guys?
Correct.
Okay.
Correct, sir.
Okay, good. Once you write this expression, then you have to put the answer like this, the way I've done. You don't have to show any more calculations. Your calculator has to do. Just do it on the run guide. Now, guys, you have KB, you have BML. If you add them, what are you going to get? If you add KB and BML, guys? If you add KML. If you add KB and BML, you'll get KML. The kg in the Bilging condition will remain same. So you can write kg in the Bilging condition is equal to kg initial. Why? Because we are following lost buoyancy method. Kg final will be 4.7. So guys, kb plus bml minus kg will give you the gml. Yes or no? So in this question, kg was given. You have to use gml. You have to use gml. And once you have all this, can you calculate the drafts now? Calculate the trim, name it by head or stern, split into TATF, apply to the height draft, and confirm that you get the answers, guys.
Yes, sir. Answer is correct.
Very good. Let's wait for some time for everybody to catch up. साहिल आंसर आएगा तो मुझे बताना बेटा, मैच होता है तो. साहिल, केशव,
Okay, sir.
please confirm when you get the answer. Abhi, let me go. Oh. My
headset was giving problem. I took it off and I walked off from the computer talking to you thinking I have the headphones on. Headset. Let me just put them on again and see. Yeah, guys, what is the status? Keshav, कहाँ तक पहुंचे? What is the status, guys? Have you got it? Yeah, इसमें guys, can you confirm now? I logged out and logged in again. I think there was some communication issue I was facing. Am I audible now?
Yes, sir.
Yes, sir.
Okay, okay. I think in between I had some problems, so I said I'll go out. Okay. केशव, क्या खबर भाई? हो गया नहीं हुआ?
हो गया सर, हो गया डन.
पक्का? ओके. अली, साहिल यादव कहां तक पहुंचे बेटा? ड्राफ्ट में मैच हुए 8.363 and
बस सर,
6.3.
जस्ट
Okay, करके बताओ मुझे. Once you are done, guys, this was a MMD question and not a very old one, May 22. So if you have been able to solve it by and large on your own, then that means this type of question, if it comes, you will have no issues whatsoever. साहिल हो जाएगा तो बताना बेटा मेरे को. I'm waiting for you. Okay.
Okay, sir.
हाँ जी, बोलो भाई लोगों. साहिल कहां तक पहुंचा बेटा?
Sir, answer 6.3666, 8. थर्ड डिजिट में थोड़ा डिफरेंस है बस 1 डेसिमल.
कितना फॉरवर्ड कितना आया तुम्हारा?
फॉरवर्ड आया सर 1 मिनट. 1.046 प्लस 1.14, 8.360. 8.360.
Okay. What is your high draft? Okay.
High draft 7.314.
Okay. BML ठीक था?
BML is 315.4.
43 उसको 3 डेसिमल प्लेस तक कर दोगे तो GML लिया. GML आया तुम्हारा 314.393.
BML आया सर 1 मिनट. Yes, sir. Okay. KG दिया हुआ था इसमें.
The GML, that's why it's coming different. You have to use GML, beta. KG is given, na? Okay. Okay, fine. So we can go to the next question, guys. No issue. So this type of question, I think you're okay. And we'll have only this type today. We are not going to close out. Guys, I don't usually close out because tomorrow you can again clarify if there's anything. So there will be a spillover tomorrow. There will be some more additions to it. But by and large, this covers your thing. Guys, then this question is again September 22. Now, again, the problem here is with the language of the question. It's the language issue. And unfortunately, it's a solved question from Captain Dubey's book. Guys, if you read this question here, what inference do you make? What do you make an inference here? And what do you make an inference here from this? Everything which is written there.
There is a watertight compartment which is divided at a height of 2 meters with a watertight flat. Just that.
No, but what does 8 meter deep compartment 8 meters deep means what?
The full compartment, there is a compartment जिसकी पूरी length जो है वो 8 meters deep है, but the water tightness is only until 2 meters.
How can the compartment be 8 meters deep? The ship is floating at 8 meters draft. Right, she cannot be just at the deck level here. You're getting my point?
Yes, sir.
Okay.
Yes, sir.
Okay. So now basically the problem here is with these words. And Captain Dubey's book is loaded with such mistakes. Let me be very blunt about it. Loaded with tons and tons of mistakes. अब ये किसी ना, I don't want to say it, ये किसी MMTI वाले ने पेपर सेट किया होगा, उनको बुक बिकवानी है, ये सॉल्व्ड एग्जाम्पल वर्बेटम उठा के डाल दिया है और उनकी ही सॉल्यूशन देखोगे. इफ यू सी हिज सॉल्यूशन, you will find in his solution this 8 meter, there is nothing at 8 meters, it is open right till the deck, whatever height it is. You're getting my point? That's what I have done is I have cancelled out these two words 8 meter deep, but I have retained them here because this is how it came in MMD, guys. Is that clear? Have you understood, beta?
Yes, sir.
Okay, so let's just quickly solve this question. So basically, what is this question as per Captain Dubey's book also? The question is, that means as if 8 meter deep word does not exist. So how has it been solved there? And obviously, why I'm insisting upon it is sometimes papers get repeated. And if the paper gets repeated, then you should not be unnecessarily confused. I'm sure the person who has not corrected the question, he would not have corrected the solution either. So we'll solve the way it is there in the book. But we will ignore these words 8 meter deep. So basically, if I ignore 8 meter deep, then I'm sure you'll agree the diagram would be like this. Length 190 meters, breadth 25 meters, floating at an even keel draft of 8 meters. Has a watertight compartment with a watertight flat at 2 meters. The length of the compartment is 15 and its after bulkhead is 20 meters forward of midship. So here is your midships. Aft bulk, so this is almost 100, so it is 20 meters forward of it. So here is the aft bulkhead, and the compartment is 15 meters long. It has a watertight flat at 2 meters. Okay, then this distance is 20 meters. Obviously, this distance is then half the length. This distance will be 95 meters. So total will be 115. Please correct me if I'm making any mistakes. And it has a permeability of 70%. So there is cargo here to the full height. There is nothing at 8 meters deep. There's no relevance of that. Permeability is 0.7. Find the drafts of the vessel if the watertight compartment gets bilged above the flat. That means this part, cargo compartment, is bilged. Is that clear, beta, now? Clear, class? Is it clear, class?
Yes.
Yes, sir.
Yes, sir.
This is, so we'll solve it and then
Yes,
I'll
sir.
send you the, yeah, this is the question. There is no relevance of an 8 meter deep here. Then we'll mark the lost buoyancy. Lost buoyancy would be this much. What will be the height of lost buoyancy? It will be d minus h. This will cause the vessel to sink. Please let me know if you find me changing my shifting goalpost anywhere. I don't usually. Wherever there is compulsion to shift, I'll announce upfront. The water will rise here. And this is now my diagram side profile. Now I make the water plane area in the bilged condition here. The water plane will be partially lost because of the cargo. Length is 190 meters. Breadth is 25. This length is 15. And this breadth is 25. Is this correct, guys? Yes or no? Please tell me.
Yes, sir.
Okay. Guys, does everybody understand? Now you see, I have not cared for the word 8 meter deep because that is not what he wants to say. It's a language issue with the question. Okay. So now let's find out the sinkage, guys. Sinkage will be equal to small l, lost points is small l, small b, height of the compartment d minus h into permeability divided by intact water plane L into B minus LBP. Can you please put the values and give me the answer? While you're solving it. Sorry, beta.
0.351.
351. Let everybody. Okay, very good. So that means D1 will be 8.351 meters. Okay. Now, next, we talk about LCG. LCG final will be equal to, so D1 will be equal to this much. D1 will be equal to 8.351 meters. The LCG final will be equal to LCG initial, will be equal to LCB initial, will be equal to L by 2, will be equal to 95 meters because lost buoyancy, even keel, box shaped. Okay, so we have this. Now look at the diagram and tell me, will LCB and LCF be same? Yes or no, guys?
No, sir.
No,
Akshay
sir.
says no. Anybody else? My question is, will LCB final and LCF final be same? Yes or no?
No, sir.
Okay. Guys, tell me yes or no. More responses. Will LCB final and LCG final be same? Yes or no? Bolo bhai. Samuel? Will they be same? Yes or no? No, sir. Okay.
No.
So that means you'll have to calculate both of them separately, beta. You'll have to calculate both of them separately. So I have included this question for two reasons here. One is to correct interpretation of the language, which seems to be misrepresented. And second, it will require calculation of both LCG and LCB and LCF. Okay. Now let's calculate LCB first. Guys, I'll put only in the notational form. Longitudinal moment of underwater volume up to W1 L1. L B D1 into L by 2 minus the longitudinal moment of underwater volume not contributing to buoyancy. That will be small l into small b into the height of the compartment which is under the water and not
D1 minus
contributing to, very good, d1 minus h into, we will put that x from here, guys. You can calculate that x value yourself, into x. Correct? So
No, sir,
into p,
permeability.
into permeability.
Permeability.
Sorry, my mistake. First permeability, then x. Sorry, first the volume, permeability, and then x. Thank you. Divided by volume of displacement LBD. Can you please calculate and give me the value, guys? Put the values, calculate and give me the values.
सर थोड़ा सा फर्क होगा 73.794
सॉरी,
सॉरी
जितना भी होगा डिफरेंस आएगा बेटे, जो भी आएगा
93.794
that is because the dB is small, नहीं तो और ज्यादा डिफरेंस हो जाएगा, राइट? ओके,
नहीं मैं अभी आंसर जो बताया उसमें थोड़ा सा डिफरेंस होगा बिकॉज मैंने नीचे वापस डिफरेंस किया है.
वो तो ज्यादा, that will be third decimal place, don't worry. वो तुम्हारा yours will be more accurate, don't worry. Let people give whatever they're giving. Yes, guys, give me the value of LCB.
$94.640.
94.6
40.
640. I can correct. I don't know. I just taken what Samuel has given. If there is a difference, please correct him. If there is a issue, please correct it. No. Is he correct, guys? How much did you get, Peter, when you took the difference in the denominator? How much did you get, Akshay?
सर मेरा आया 93.794.
नहीं, वो ज्यादा डिफरेंस इतना नहीं आना चाहिए. One of you is wrong. It cannot be that much. It cannot. Guys, what is majority of you getting?
93.793.
Okay, I'll write that. 93.793. So somebody who gave 94.640, can you please check what did you miss out? I hope you have taken it D1 minus H. D1 minus H will be 6.351. I think you might have taken 6 here. Maybe you messed up here. That's all I can see.
I took 5.3.
Okay, by mistake, then it's okay. If you took by mistake, then it's okay. Be careful. Guys, is 93.793 correct? Yes or no? Please confirm.
Correct, sir.
Okay. Now let's calculate LCF by moments of areas, guys. So you'll have to calculate that also. You can't get away this time. Longitudinal moment of the whole water plane. So capital L into capital B into L by 2 minus the longitudinal moment of the lost water plane. Small l into small b into p is the lost water plane. X is the longitudinal lever divided by the intact water plane LB minus LBP. Please put the values and give me the answer. If anybody has not understood, you can ask me. If you have not understood,
93.391.
so you can see that difference now between LCB and LCF, 93.391 meters. Please validate if it is correct. If there's any correction, we'll correct it. Is that correct, beta? 93.391, please confirm.
Yes, sir, correct.
Yes, sir. 93.391.
Very good. Now we'll go to the water plane area for BML. First, we will mark the center of flotation at an approximate distance, which is naturally aft of midships. So LCF is 93 point something, half will be 95. So if center of flotation is here, G1 will be here. We draw an athwartship axis through it, that is FF. And this distance you've already calculated as 93.391 meters, guys. Now BML will be equal to IFF of the intact water plane upon volume of displacement. It will be IFF of the lost water plane. Sorry, whole water plane, my mistake. Whole water plane minus IFF of the lost water plane divided by V. But FF is not a standard axis for neither the whole water plane nor the lost water plane. So through G1, we draw this axis. We have been marking is at XX, whatever you've been marking, no problem. This distance is 95. That will give us this distance of X1. X1 will be equal to 1.609. Am I right, guys? X1 is 1.609.
Yeah, correct, sir. Correct, sir.
Yes, sir. Yes, sir.
Likewise, we'll mark the geometric center of the lost water plane, draw athwartship axis through this YY, and we'll mark this distance as X2. Now, what is X equal to? X is, this is 95 plus 20, 115, 115 plus 7.5. X is 122.5 meters.
29.109.
29.109. Is it right, guys? 21.109.
Right, sir. Right.
Okay. So now we are good to put the values. IFF of the whole water plane. So first let me write in that box brackets. IXX of the whole water plane minus plus or rather area of the whole water plane into X1 square minus IYY of the lost water plane plus area of the lost water plane into X2 square upon volume of displacement. Can you please take it on from here and give me the BML? Give me the BML.
Three 370.382.
370 point.
0.382.
Okay, subject to correction as the yield comes more from the class. Please confirm once you get BML, guys. Guys, can somebody validate BML 370.382? Is that correct?
Yes, sir.
Okay. Now, guys, at this stage, once you get BML, always go back to the question and see if kg is given. Please go back to the question and check for kg. Is the kg given in the question?
No, sir.
Yeah, because you must every time validate whether GML will be used or BML will be used, right? Okay. Now, if GML cannot be used, now can you please find out the trim and name it by head or stern and get the drafts forward and aft? I'm not done it, but I'm writing the drafts from Captain Dubey's solution.
8.666 forward.
So I'll just share the drafts from his solution. Don't worry about, now this is where I was saying that if Keshav goes through his solution, he'll go for a spin and then you'll say whether he's right or wrong. Why? You don't break your head on it. Just focus on doing the right way, the right things. 8.666 is Dubey's answer and 8.047 meters, right, guys? These are the answers. I've copied from his solution.
Sir, यही answer.
And guys, I have shared the solution also with him. Now you see, go through his solution and go through your solution and then decide which way would you like to do. And then you'll feel the difference better. Then you'll realize the difference. Yours are very crisp steps, very crisp steps. He's also calculated MCTC. Now all these things will cost you time. Why unnecessarily waste your time here when you can simplify the formula? So solution also I've shared. Captain Dubey's solution I've shared on the group. I'm sure you would have received. But don't worry about anybody's solution. Take the question, solve the question your way. If your answer is matching, why bother how somebody has done it? Just move on, man. Don't break your head with it. I went through the solution because I wanted to sort out this 8-meter deep insertion of 2 words out there. And of course, his solution also does not mean that there is another flat at 8 meters. And therefore,
so that is what I would feel if I got this question. Like
I would also, if I read English correctly, then there should be a second flat at 8 meters also, correct?
Yes, sir. That is what I also felt. Yes.
No, that's what I'm saying. There's a problem with the English. It's not about you or me being right or wrong. There's a definite problem with the question. And unfortunately, this question has come in MMD. And that's why I'm emphasizing upon it that let's solve it the way it has been solved in the author's book. Why? Because if somebody did not care to correct the question, he will never correct the solution. Don't worry about it. He would have copied the same solution. Okay.
Yes, sir. Yes, sir.
Okay, but if you still want to make another watertight flat, it's up to you. I have given you my reason why I'm telling you ignore these words, because I'm sure nobody would have calculated by putting another flat there. Okay, yes, rest is your take here. I can only suggest you, right? But if I read this question, there will be one watertight flat at 2 meters and another watertight flat at 8 meters. But if I put at 8 meters, then it does not remain 8 meters deep. That means, do I put it at 10 meters or do I put at 8 meters? Because first he says there is a watertight compartment 8 meter deep, and that 8 meter deep has a watertight flat. That means there is another watertight flat at 6 meters from the tank top, right? If you strictly read the sentence, that is what it means, right? So anyway, let's not break our head with it. There is a language question. Okay, guys, I think such type of questions you will be able to handle now. So we have done 2-3 questions from past MMD. I think we have done 3 questions, guys. 2 and 3. We have done 3 questions from MMD. No, only 2 questions, sorry. This one, May 22. And then this one, Captain Dubey's. Okay. Now, guys, whatever I had to do today, I have done. What have we done today? We have done the trim issues related to a ship which was earlier E1 keel. initially even keel. We did not have to calculate LCG. We could reason it out and get the LCG. Okay. Tomorrow we'll see if the vessel is initially trimmed, and then we'll talk of a vessel if the compartment has any. Now here we have already taken with permeability. The compartment can be empty, the compartment can be forward, compartment can be aft. There were two questions in which LCB and LCF were equal. In this question on display, LCB and LCF were different. So we have covered that variation. You know when they'll be equal. We have also covered a question in which GML was used. In another two questions, BML was used. So all those variations have been covered well in these three questions. Tomorrow I'll do the remaining part and close it out. Tomorrow I'll connect you from Bangalore. I'll be leaving for Bangalore in a while from now, and I'll connect for next few days. I'll join you from there. So 9:30 tomorrow, guys. Is that okay?
Yes, sir.
Okay.
Sir, can you
See-
also send this advanced problems, problems?
Yeah, those past paper prior learning one. No?
Sir.
I'll send these questions also that we have done the sheet for today. Okay. Okay, guys.
Okay.
Chal. Take care, guys, and please practice.
Thank
now you
you.
can practice from your best is practice past papers and match answers with each other. If there is a difference or if there is a discussion on some certain issue, we can take it up in the class beta. This question which Keshav had brought, this GMT one where 1,000 ton meter FSM was given. This question also just pay attention because this is also a little confusing because 1,000 ton meter FSM is given in the initial condition. Then if you start allowing the free surface of the in the initial condition of the compartment, it goes much more. Then you have to just use your common sense and say, no, this must be the FSM excluding this tank. And in any case, after bilging under lost buoyancy method, that free surface does not bother you anymore. Correct, beta? Am I right?
Yes, sir.
That question that we did in the beginning. Okay. Okay, guys. See you 9:30 tomorrow then. Chalo, take care.
See you.
Okay, bye. Goodbye, guys.
Thank you.
We'll connect tomorrow. Bye. Thanks.